Scary, huh? It is the only natural disaster we cannot predict. Earthquakes can hit any time, at any magnitude, often with very little warning. But there's some exciting new research out of Sweden that may bring us closer to being able to predict the big one. Now, the gist of it is this. Scientists have found that the chemicals in groundwater change before an earthquake hits. And we're not talking minutes or hours or days or even weeks here. We're talking 4 to 6 months ahead of the earthquake. Pretty significant. Now, Johanna Wagstaff, our meteorologist and seismologist, is here to explain how all of this might work. So, Johanna, how can changes in the groundwater be used to predict quakes?
Well, Andrew, it really has to do with precursors before an earthquake. So looking at anomalous events that happen before a quake, things like animals acting strange, gases being released from the earth. So this goes into this field of study known as a precursor study. But until this point, we really haven't had good data to be able to make a connection. All of these events don't always happen before an earthquake. But this study used a simple and systematic approach with good results so far. They basically sampled groundwater, a similar procedure to this. They dug down into a 100-meter bore well in northern Iceland, took samples every week for 5 years. So that's a lot of data. And they analyzed how the chemistry of the groundwater in the aquifers changed over time. And they did find a spike in the chemistry of that groundwater about 4 to 6 months before two pretty significant earthquakes, both 5.0 magnitude or higher. So these are really good results. And I spoke to the lead researcher of this project earlier this morning via Skype in Sweden, and here's more on how those changes happened in the water.
So what we do know is that 2 or 3 aquifers got linked together somehow, presumably because of fracturing in the rock or some change of permeability. And the waters between those aquifers mixed, and that's what gave us our chemical signal. So we're pretty confident the chemical signal we see is mixing of water between 2 or 3 aquifers. The problem for us is trying to understand how that actually happens, because we're quite far from the earthquake. The stresses of the rock are going to be very, very low. So there isn't really much reason for a lot of fracturing to occur.
So pretty incredible they were able to detect these changes so far away from the epicenter, but goes to show there's still a lot we don't understand about the mechanisms of what's happening under the ground. We know there's an incredible amount of stress that builds up under the earth, but we don't know exactly what those changes are happening. It's still a very interesting study.
Yeah, and I guess this is just the beginning. I mean, they're going to have to investigate and take these measurements.
And they'll keep this study going for years to come.
And so how close are we then to be able to use this data to actually predict when a quake is going to strike?
Well, I want to say that we're close, but unfortunately the answer that we don't want to hear is we're still a long ways away from predicting earthquakes. This is a great step in the right direction, and it's still the ultimate goal of a lot of research, including this one.
Of course it's a dream. What is exciting is that the data is pointing to the fact that there may be a physical or chemical change before an earthquake. That's, of course, a prerequisite if one's ever going to be able to predict them. If nothing happens before them, there's nothing to go on. So that's at least a small step forward, but I would not dare to make any statement whatsoever about earthquake prediction in the future based on our results.
See, for a precursor to actually help us in predicting earthquakes, it has to happen every time. We can't evacuate entire cities when sheep start acting strange, which is why this study is so interesting. And it does have a connection globally. This isn't the first time this study has made a connection to groundwater. In fact, after the 1995 Kobe, Japan earthquake that killed 6,400 people, a pretty devastating earthquake for the country, scientists actually looked at bottled water that was taken from the groundwater, the aquifer in that area, and they looked at the dates, the bottling dates on that water before and after the earthquake, and they noticed a spike in the chemistry before the quake happened. But unfortunately there wasn't enough data at the time to make that connection. But definitely moving forward, we need more global studies to match up this pretty interesting correlation.
Right, and so, you know, that research referred to it as a dream, this idea of earthquake.